Hi, today I am going to derive capacitor charging equation. For that, I am considering a simple RC circuit. So, Vs is the input voltage, R is the resistance, and Vr is the voltage drop across the resistance, C is the capacitance, and Vc is the voltage drop across the capacitance, and Vout is nothing but the voltage drop across the capacitance. So we need to calculate what is the V out, what is the charging equation for the capacitor. So for that, first I am taking the KVL rule. So the KVL rule states that the in a closed loop, the summation of all the voltages must be 0. For that I am taking that Vs is equal to Vr plus Vc, or we can say that Vs minus Vr minus Vc, that should be equal to 0. I am modifying that equation. I am taking that Vs is equal to Vr plus Vc. And also we know that voltage drop across the capacitor is nothing but the V out. So I am taking that Vc is nothing but V out. And also voltage drop across resistance, we can write that Vr is equal to I into R. Current through the resistor into resistance value will give the voltage drop across the resistor. And also voltage drop across the capacitance, we can define that total charges divided by the capacitance value. So I am replacing this VR and VC by I into R plus Q by C. So I am rewriting this equation. Input voltage Vs equal to Vr is replaced with I into R and Vc is replaced with Q by C. And also we know that the rate of change of charges with respect to time is nothing but the current. So I am replacing this current, this I with Q dq by dt. So here V input voltage equal to, I am replacing I with dq by dt and returning the R plus Q by C. So I am rewriting this equation. I am taking this whole thing to the left side. So R dq by dt, that is equal to Vs, and taking this Q by C equation to the left side. So Vs minus Q by C. So finally we'll get R dq by dt is equal to Vs minus Q by C. So after that, in the next step, I am taking the LCM for this equation. This is a kind of fractional equation, right? I am taking LCM. So if I take C as LCM, so Vs into C minus Q divided by C. So finally we'll get this R dq by dt is equal to Vsc minus Q divided by C. So dq by dt, I am taking this R into the right hand side. So here it is in the multiple of this d by dq. If I take to the right side, it will become divider. So R will come here. Finally dq by dt is equal to Vs into C minus Q by RC. After that, I am taking this numerator term into the left hand side and this denominator term into the right hand side. So what will become? This will become 1 divided by Vs into C minus Q into dq is equal to 1 by RC, this dt term into this side. So after that we have dq and dt term. So for that we are integrating both sides. So here we are integrating with the limits 0 to q, and here we are integrating this side with 0 to t with the limit 0 to t. So we have the complex term here to integrate. So what will you do that? For that I am considering a simple term u, that is nothing but Vs into C minus Q. And if I only replace this equation, that is not correct. We need to replace this dq term also. For that I am deriving du term with respect to q. So du by dq is nothing but, we know the Vs into C minus Q is u. We are applying derivative here with respect to dq. So we are deriving this term with respect to dq. So if you do that, will become derivative of Vs into C by dq minus dq by dq. If we derive this thing, this whole thing considered as constant, and it will become 0. And we are remaining this term as C, and dq by dq nothing but 1. So we can replace du is equal to minus dq, or we can replace dq by minus du. So here we are considering this term, right? So 1, I am replacing all this term, taking all this term as u. So I am written it 1 by u, and I am replacing this dq by minus du. So 1 by u minus du. So limit as taken same, 0 to q, 1 by u minus du, that is nothing but 1 by rc, 0 to t into dt. So I am taking this minus sign into the right hand side. So the equation become the limit from 0 to q of integration, the integration of 1 by u du, that is nothing but 1 by rc integration of 1 dt. dt is nothing but 1 into dt. So if we integrate this, 1 by u is nothing but ln u, and the limits is 0 to q. And in the right hand side, 1 by rc is nothing but the constant. We are taking out the constant out, and the integration of 1 is nothing but the t. So t, and the limits are 0 to t. So I am replacing the u value here. So u is nothing but Vc into C minus Q. So I am replacing the u value, and minus 1 by Rc, upper limit minus lower limit. So I am applying upper limit minus lower limit to the t value. So here if we consider, so ln Vs into Q minus Q, upper limit is Q. I am replacing Q value by Q, and in this minus ln Vs into C minus lower value of Q is 0. I am already removed that. That is equal to minus this T divided by Rc. So ln of Vs into C minus Q divided by Vs by C. How it will come? So we know the logarithmic formula, ln A minus ln B, that is equal to ln of A by B. The negative term of the subtraction mode will become to denominator of the ln term. So that is how I have taken here. Ln of Vs into C minus Q minus ln of Vs by Vs into C will become ln of A minus B. So ln of Vs into C minus Q divided by Vs into C, that is nothing but minus T by Rc. Okay, and also we know one more formula, one more logarithmic property, ln B is equal to C. We can write it down as B is equal to logarithmic base power of C. Ln is nothing but having the base value of E and the power C. So B is equal to E power C. So I am writing it down. This is the B value, B E power C. So Vs into C minus Q divided by Vsc is equal to E power minus T by Rc. After that, I am taking this Vsc into the right hand side. So Vsc into C minus Q, this numerator term, that is equal to, this will go here, Vsc E power minus T by Rc. So I am rewriting this equation. Q is equal to Vs into C minus Vsc E power minus T by Rc. So Vsc and Vsc is common in these two parts. So I am taking Vsc as common. So Q is equal to Vsc. So if I take common, 1 minus E power minus T by Rc is remaining. So I am taking this C to left hand side. Q by C is nothing but Vs 1 minus E power minus T by Rc. So Q by C, we are already considered that Q by C is nothing but Vc and Vc is nothing but V out. So Q by C nothing but Vc, that is also we can say that is V out is equal to Vs of 1 minus E power minus T by Rc. So finally we got that V out is nothing but V of 1 minus E power minus T by Rc. This is for the capacitor charging formula in an RC circuit. So for the capacitor discharging, we need to consider the same thing. If we derive in the same way, we will get it. V out is equal to V in E power minus T by Rc. This is for the capacitor discharge formula. Thank you.